morning. Today we're going to go over the review that is due today. I would like you to make corrections as we go over it. If you don't have time to get all your corrections made, that's fine. There will be a copy of the notes from this lesson posted to the website, and you can make corrections then. This review, along with our second review, are both due tomorrow. You will hold on to both of them today. You will not turn anything in today. But before your test tomorrow, I'd like you to turn in both assignments. Hopefully, you'll be set after hearing this video. If not, if you have additional questions that your classmates aren't able to help you with today, then feel free to come in tomorrow. I'll be available after 7:45 to answer questions. Okay, the first one, y equals x squared. This is the parent graph for a quadratic. So if we square positive 1, we get 1. If we square negative 1, we get 1. If we square positive 2, we get 4. If we square negative 2, we get 4. And then there's our function. Okay, number 2 is y equals 1/2 x cubed. This is a cubic function, so we choose numbers that we cube. There is no shift, so we're going to start off at the origin. 1 cubed is 1, but we're going to take half of that. 2 cubed is 8, but we're going to take half of that. Negative 1 cubed is negative 1, but we'll take half of that. Negative 2 cubed is negative 8, but we'll take half of that. And the reason we're taking half of that is because the 1/2 in front here causes a vertical compression. And there's our function. Number 3 is an absolute value. Y equals the absolute value of x plus 1. So we're going to shift up 1 this time. We're going to do the absolute value of 1 is 1, of negative 1 is 1. The absolute value of 2 is 2, of negative 2 is 2. The absolute value of 3 is 3, negative 3 is 3. And then we'll draw in our absolute value. Okay, this actually is an even function because we didn't shift it left or right any. So you weren't asked that on the homework, but you should be able to recognize that. That function has even symmetry, as does the next one. It is another absolute value, but this one's just been shifted down 3. Now this also has a vertical stretch. So instead of 1, 1, we're going 1, 2. Instead of 2, 2, we'll go 2, 4. And the same in the negative direction. So this is our V that is just a little more narrow. All right, number 5. Y equals the square root of x minus 1 plus 2. So in this case, we have to choose numbers that we can take the square root of. So we'll do our shift over 1 up 2. And now we'll pick numbers that we can take the square root of. The square root of 1 is 1. The square root of 4 is 2. And it makes what we call the eyebrow. Now, I haven't talked about the domain and range on these because it's on your second assignment. But with the eyebrow, that's the one that also has a restriction on the domain. So watch out for that when you're doing your homework tonight on that second review. The square root function also has the restricted domain. Okay, number 6 is another absolute value, but this time it has a vertical compression component to it. So if we go left 2 and down 4, that's where we'll start this one. Left 2, down 4. And instead of going over 1 up 1, we go up a half. Instead of 2, 4, we go 2, 1. And this makes a much wider absolute value. That causes that vertical compression. Okay. And let's do the next 6. All right, number 7. Y equals the cubed root of x minus 2. So we have to choose numbers that we can take the cubed root of. So we're going to shift right 2 with our transition point here. And we can take the cubed root of 1, which is 1. We can also take the cubed root of 8, which is off my graph. We can take the cubed root of negative 1, which is negative 1. And the cubed root of negative 8 is negative 2. And so this one would look something like this. All right, number 8. this is a very interesting square root because we have a reflection, but this time our reflection is over the y-axis instead of the x, and therefore instead of going down, it's going to go left. So this gets shifted up 2 units, and now we're going left because we have a reflection over the y-axis. So we'll go left 1, up 1, left 4, up 2. Okay, I'm going to pause there for just a second, let you catch up, and we'll be right back.
Just kidding.
Hey, Jay. Will you go get
You want me to tell that to all of them? Okay, I'll stop that out and tell them to go to Spencer.
Okay, back for number 9. On this one, we have y equals negative 3x cubed minus 2. So we're going to start down here at negative 2. Now, this is a cube, so I'm cubing, but I'm also multiplying by negative 3. So instead of left 1, down 1, because negative 1 cubed is negative 1, we're actually going to go up 3. And that's the only point on the left side that's going to fit, because the next one would be negative 2, negative 8, which makes it negative 2, positive 24 when I multiply by the negative 3. Doesn't fit. So if I go right 1, instead of up 1, I'm going to go down 3 because of negative 3. And those are my only points that fit on this graph. And so those are the only ones I would expect you to graph. All right, number 10. We have y equals 1/2 the absolute value of x plus 2. So we're going up 2. And once again, we have that vertical compression. Number 11, we have y equals 3x squared plus 1, so we'll go up 1. And this is another squaring function, but we have to triple our moves. So the only thing that will fit is that first one, and we should make this look like a curve. Mine doesn't look so hot, but hopefully yours looks better. Number 12. Negative. Love those negatives out in front. The negative out in front causes a reflection over the x. All right. So this one's going to be shifted up 1. It's a cubed root. So we're picking numbers that we can take the cubed root of. Like the cubed root of negative 8 is negative 2. So if I went negative 8, normally I'd go down 2. But because of the negative 2 up in front, I'm actually going to go up 4. Instead of left 1, down 1, I'm going to go up 2 because of the negative 2. And then the reverse happens on this side. Whoops, missed it. So I'll go right 1, down 2, right 8, down 4. And then I'll draw in my function. Okay, let's keep going. Number 13. Y equals negative 2, x minus 1 plus 4. So we're going to go right 1, up 4, but this time we're opening down with our absolute value, and our moves are doubled. So it'll go this way. Number 14. Y equals negative 2 square root of x plus 4. So I have to pick numbers I can take the square root of. I'll start over here at 0, negative 4. 1 is 1, 4 is 2, 9 is 3, but I'm multiplying by negative 2. So it's over 1 down 2, over 4 down 4, over 9 down 6. So this eyebrow opens down like that. Interesting domain and range here. This goes from negative 4 to infinity, and this range goes from negative infinity to 0. Didn't ask you for that, but that's what it would look like. On number 15, through your curveball. This is just a line. That's slope-intercept form. So we're going to start down here at negative 5. Then we're going to apply our slope, rise over run, up 3 over 1, up 3 over 1, and then we have a line. You won't see this on your quiz tomorrow, but you should be able to do a line anytime I ask you to. Okay, number 16. Y equals negative x plus 1 cubed minus 5. So we're going to, that's x plus 1, so we'll go left 1, down 5. And we go left and up because of the negative. And up 8 because of the negative. And then down 1 on the side, and that's all that'll fit on my graph. All right, number 17. We have y equals negative x cubed plus 5. Very similar. We're just up 5, and our moves are reversed. Very similar to the last problem. So these are totally decreasing now instead of increasing. Here we have a square root that has a vertical stretch. We have no shift. So we're picking numbers we can take the square root of. The square root of 1 is 1, but we double it. The square root of 4 is 2, but we double it. So this one's opening up like this. All right, let's take a look at those last 6. Okay, so number 19 is another line. 2x minus y equals 1. If we move the y to the right and the 1 to the left, we get 2x minus 1 equals y. Now we're in slope-intercept form. And we do rise over run, and we have our line. Once again, you won't have a line tomorrow, but we should be champs with lines. All right, x plus 1 cubed plus 2. Left 1 up 2. Normal moves. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8. Positive 1 cubed is 1, and that's all that will fit on my graph. 21. Y equals the opposite of the square root of x plus 1. So we're going left 1, and because of the negative, we're opening down, and we're choosing numbers that we can take the square root of, and there you go. 22. Back to absolute value, so this one will be the v. Hopefully, after doing all of these, we can immediately recognize the shape of a graph. And that was the purpose of this assignment, so that we don't have to think about our moves, that we now know our moves. So when we get to the test tomorrow, we have plenty of time because we don't have to figure anything out. We just know it. All right. Number 23, this one's up 2. It's negated here and here, which means I go left and I go down. So this one is the square root function that opens left and down. And 24 is our last square root. We have x minus 1 plus 2. So we go right 1, up 2, and we're taking half this time. So this one is over 4 instead of up 2. We're just going up 1. And there's number 24. All right, now we're going to look at those questions that were in the middle of this section. They are. And I'll scroll down and we'll work on these. What I was looking for number 1 is really just words. How would you, and I think yours says quadratic instead of cubic. So we'll change that to quadratic. What you would do is shift to the translation point and apply your moves. That's what we're going to do for any function in transformational form. We'll shift to the translation point and apply the moves. Okay, square root function that has a domain from -3 to 0. I'm going to sketch it. -3 to 0 would have to start over here and go right. So what would that function look like? Well, it would be y equals the square root of x plus 3. Now, you truly could have anything added to the end or anything multiplied out in front as long as it was positive. Actually, positive or negative. It could open up or down. So you just have to have this in it, and then you can add extra. Absolute value function that moves a parent left 3 units. So we're going to go left. We do opposite, so we'll put plus 3 in there. A cube root function that has a translation point here and is decreasing. So if it's decreasing, it has to be going down. So we need to negate the function. Cubed root. We want to go left 7, so we'll put a plus 7 under the root and a minus 3 at the end. Okay, now we'll work on solving these problems. Part 3, let's solve. So number 1 in the solving part is x cubed equals negative 216. We can take a cubed root of a negative, so we take the cubed root of both sides, and the cubed root of 216 is negative 6. Negative, negative. Number 2, we have x minus 5 cubed equals 125. So we're going to take the cubed root of both sides. The cubed root of 125 is 5, so we get x minus 5 equals 5. We add 5 to both sides and we get x equals 10. Number 3, 2 times the square root of x plus 2 equals 8. We subtract 2 from both sides. We get 2 roots of x equals 6. Divide both sides by 2. So we get the square root of x equals 3. And to undo a square root, we would square both sides. So x equals 9. Number 4, x squared minus 7 equals 74. We would have to add 7 to both sides. And so we get x squared equals 81. And so we take the square root. Now, when you take the square root, you get plus or minus. Anytime it's an even root, plus or minus. Odd roots, no. Even roots, yes. Number 5, we have 1/4 x cubed equals a half. So how do we get rid of the 1/4? Multiply by the reciprocal. And when we do that, we get x cubed equals 2. So we need to take the cubed root. Now, we don't know the cubed root of 2, so that's how we have to leave our answer. And that's what I would want you to do on the test. We're going to simplify any of the radicals. It doesn't simplify, so we just leave it like it is. All right, number 6, our first absolute value. Now, absolute value, like quadratics, will have 2 answers, if they have any. So the first thing we do is isolate the absolute value. Now we know that all of this stuff can equal positive 7, or all of this stuff can equal negative 7, so we'll break it up. X minus 7 equals 7, x minus 7 equals negative 7, and we solve both of these. So we add 7 to both sides, and we get x equals 14. We add 7 to both sides, and we get the other answer is 0. All right, number 7. The square root of x equals 16. So to undo a square root, we have to square both sides. And hopefully this is one of your perfect squares you know. 256. Number 8. 2 times the cubed root of x plus 1 equals negative 16. So we divide by 2. So we get the cubed root of x plus 1 equals negative 8. Now, this one has a solution. If this were an even root, it would be no solution, but it's an odd root. So when we cube both sides, it's okay to have a negative. We get x plus 1, and 8 cubed is negative 512. And then we subtract 1 from both sides, and we get x equals negative 513. Negative 513. All right, number 9. We're back to an absolute value. Okay, this is a good one because it's got more things involved, and it's an absolute value inequality. So we have to have our answer written 3 ways: as an inequality, as a graph, and as an interval. So we'll add the 5, and we get the opposite of x plus 7 is less than 12. So then we divide by negative 1. And then we get the absolute value of x plus 7 is, when I divide by negative, that switches the inequality. So it's actually greater than negative 12. Now, this one, there's not even a need to split, because every absolute value is going to be greater than a negative number. So I automatically know the answer to this is all real numbers, which if I graphed it, the entire graph would be shaded, and the interval would be from negative infinity to positive infinity. All right, let's take a look at number 10. X plus 19 squared minus 5 equals 20. Add 5 to both sides. take the square root of both sides. When I take a square root, I get plus or minus. So when I break this up, I get negative 19 plus 5 and negative 19 minus 5. So my answers are negative 14 or negative 24. Just a few more. 2 more and we're done. Number 11. The absolute value of 2x minus 1 plus 8 is greater than or equal to 11. The first thing we do is subtract 8 from both sides. So now we have isolated our absolute value. Greater than, greater, ends up being an or. So when we split it, we have 2x minus 1 is greater than or equal to 3. Or, greater, or 2x minus 1 is less than or equal to negative 3. So 2x is greater than or equal to 4. X is greater than or equal to 2. 2x is less than or equal to negative 2. X is less than or equal to negative 1. So here's the inequality. First answer. Second answer is your graph. So we have a closed circle because of the equal to on negative 1 going left. A closed circle on 2 going right. Or goes apart and comes together. Number 12, 5 times x plus 1 equals 80. So the first thing we do is divide both sides by 5. And when we do 80 divided by 5, we get 16. We take the square root of both sides, so we get x plus 1 equals positive or negative 4. So we split it. X plus 1 equals 4. X plus 1 equals negative 4. So x equals 3 or negative 5. Okay. If you didn't catch all these corrections as the video is playing, go to the website and the answer key will be posted.